Hello, and a very warm welcome on behalf of NTI Audio. Well, let us assume that you received the task to execute noise monitoring, for instance, close to an airport or a construction site, whatever, and you are responsible for collecting the data from this recording station. You're also responsible to presenting the results to third parties like the customer, the public, or whatever. Well, this process is the topic of today's presentation. My name is Markus Becker. I'm moderating this webinar and I am assisted today by Paul Sinclair. He is basically taking care of the incoming questions and comments. We have prepared the following topics for you. We start with a brief overview on the concept of noise monitoring, the required equipment. We will introduce you to the possibilities to connect your noise monitor with your PC. We will also give you an overview on the data collection and the presentation alternatives and options. We will also show you the new system self-test, what stands behind that. We will then dig a little bit deeper into the Noise Scout system and the WebSocket data collection details before we show you our practical presentation. After that, I will summarize the most important information from this webinar and add some more hints and tips. At the very end, I will take a look at the questions that have popped in and possibly provide some more comments. I expect that this presentation will last about half an hour. Well, the fundamental intention of noise monitoring is to measure and record different sound levels at remote locations. For that purpose, we need a noise monitor. A noise monitor is always a microphone, a sound level meter, and a device that allows you to forward, to transmit the recorded data to your PC, where you would analyze the incoming data. Another important or helpful feature of a noise monitoring system is that it creates alarms whenever a sound level would exceed a given threshold. These thresholds are typically defined by the national standards in your country, and they apply for different applications, construction sites, airport, whatever. And they define that if a sound level exceeds a certain threshold, action needs to be taken, and for that reason our system is able to create alarms in such cases. Well, after having collected and possibly partially analyzed the data, you may want to share them with your colleagues for an internal discussion, or you want to forward them to your customer, to the person who has given you the task to execute this noise monitoring, or even you want to share this information with the public, so to make it visible to anybody who is interested in the current status of your noise monitor. But first you have to, of course, take care that the noise monitor is connected to your PC. This is typically established via the internet or a cloud server. And on the technical level, you can do that via mobile data, be it 3G or LTE or 4G network. If a LAN network is available in the vicinity, you can also connect the noise monitor via an Ethernet cable, or as a third alternative, you can use a Wi-Fi network, suppose it's available where the noise monitor is located. Our system would support all three methods. Well, now let's talk about data collection. Our system basically offers 3 ways to collect the data from the noise monitor. We have the managed mode and the gateway mode under the Noise Scout platform. And as a third alternative, you could also collect the data by using a WebSocket. Let us take a look at the key characteristics and the limitations of these 3 options. The managed mode is a very straightforward access to the noise monitor via the Noise Scout server cloud. So it's a very easy to use and helpful feature which provides all the required information. It is also able to automatically generate the aforementioned alarms in case that a level exceeds a given threshold. A limitation of the managed mode is that the layout and also the data handling is predefined. In most cases, it covers the demands of the customer, but sometimes a customer wants to implement his own solution. And for that purpose, we also support the so-called gateway mode. Here you have again the unrestricted access to all noise monitors in both directions, which means you can collect the data, but you can also control the settings, for instance, of the noise monitor. And this is done via an SFTP server. Furthermore, you can decide by yourself which way you want to collect the data and how to analyze them. However, on the other side, you have to take care on this SFTP server connection and on the data collection and analysis. So all this data handling must be executed by yourself. Third option, the WebSocket, provides full access to the real-time noise monitor data that are acquired. And this is typically used for customized presentation, for instance, by integrating this data into your website. However, same as with the gateway mode, keep in mind that this presentation must be programmed by yourself. One more hint, we have already presented a webinar on unattended noise monitor solutions. You will find the recording of this webinar on our website, so I will not dig too much deeper into this topic. I will more focus on the one of this webinar. So, having collected the data, the next step after the analysis would be the presentation. And here you need to know, of course, which data are available, which data could be presented to third party. Of course, there are the sound levels on a daily or hourly audit basis. You could also publish the periods and limits. So, for instance, that during the nighttime, the limits are tighter than during the daytime. You could also show the alarms that have occurred. The system status is another bunch of data that are available, covering the power supply status, the data network that is used, the temperature in the noise monitor, or also the data from the system self-test. This is, by the way, a new feature which is connected to the M2340 microphone, a new product from NTI Audio that has just been released. I will come back to that feature just in a minute. And the third package of data that is provided, if you have a weather station connected to your noise monitor, you can, of course, also publish or present the wind speed and direction, which has, of course, or can have an impact on the measured sound level. Well, the next question is, to whom do you want to present this data? For instance, to your colleagues or the customer or the public, as mentioned before. Well, talking about your colleagues, you would probably share all the data with them to allow a comprehensive discussion of the situation. Talking about the customer, you may renounce on certain information. For instance, the alarms are not necessarily need to be forwarded to the customer, or also the data from the system self-test is not mandatory that to be shown to the customer. And when we talk about the public, the list of information should be even shorter. The periods and limit is something that is not necessary to be shown, same as the alarms, and you would certainly not forward the system self-test data to your to the public. Well, the third question you have to ask yourself is via which platform, in which way you want to present this data. This has already been covered a little bit on the previous slide, and I will come back on that later. Okay, now let us dig deeper into the system self-test. The motivation behind this feature is that the microphone capsule of a noise monitor is permanently exposed to environmental impacts. This can be dust, this can be temperature changes, this can be moisture, rain. So actually the microphone capsule is the most exposed part of a noise monitor. And we want to know whether the microphone capsule works fine, because if it is corrupted, if it is impaired by this environmental impacts, this has of course a direct impact on the correctness of our measurement data. And we as the, or you as the provider of a noise monitoring station, you must be sure that all measured data are correct. So how can we make sure that this is the case? Well, the answer is quite simple. You need a kind of a self-test that allows you to verify the correct operation of the microphone and, of course, all of the subsequent signal chain to your PC. And we do that by using a new feature in this M2340 microphone, which is called the system self-test. And this works like, as I can show you now. Here we have the symbol for the microphone. A microphone, if we translate that into the electrical world, would be a capacitor. So the changes in the sound level would create a signal on that capacitor, which will be preamplified and forwarded to the rest of the system. Now, by adding a generator, which can be connected to that system here, to that electronic, we can create a new situation where, as soon as we close this connector here, the switch, we will create a situation where we know exactly how the system should behave. Let's suppose we have a quiet environment and we have only the signal coming here from the generator. We can predict exactly how the whole system should behave. We can analyze the data, that is the signal that is coming out of our preamplifier, and if it is behaving as predicted, we know the system is working fine. However, if this capacitor representing the microphone capsule has a problem, is not working correctly, we will notice that immediately, because the outcoming signal will look differently as we would expect it. Keep in mind that this electronic here is all part of the new microphone, and so it's included in here. So we can, with this solution, really verify the whole signal chain from the capsule through the whole transmission line. Keep in mind you need an M23 microphone to execute the system self-test, and also this procedure, the self-test, is initiated via the noise monitor, and the response, which means the data that is returned, will only be analyzed by the PC. So the system here in front cannot execute this analysis. It can only forward the data to the PC where the final analysis takes place. Few more words about the system self-test. We are using a square wave for this purpose, actually two square waves with two different frequencies, 46.9 Hertz and 375 Hertz. They are creating harmonics. You see just a few of them here. There are more. And now by analyzing these harmonics, you can see here the fundamental frequency, the 46.9 Hertz. Here are the harmonics that have been created. And by analyzing this spectrum, or doing the same for the 375 Hertz signal, we can determine whether the system is working correct or not. Now, a few more words about the Noise Scout managed mode. In this mode, the Noise Scout platform collects all the recorded data from the noise monitors, and it supports the export of this data to the Data Explorer software, where you can execute the individual analysis according to your demands. Furthermore, you can create standardized reports from the Data Explorer software. This topic here has already been covered in previous webinars, so I will not say too much more about that. It's just a very easy to use, very intuitive operation. Just try it out and make your own decision whether this is feasible or whether this would cover your demands. However, if you prefer to establish your own data handling and analysis, use the gateway mode. You need to connect your noise monitor via SFTP server, as mentioned before. You have to take care yourself of the data collection and the analysis, but you're of course much more free in deciding the way how you want to do that. But this is the drawback, so you have to take care of all these issues, and this is the reason why I did not show any picture on this slide, because this is absolutely up to you how it will look like in the end. Now, the third option, as you remember, the WebSocket. The WebSocket is a possibility to collect data, real-time data from a Noise Scout server, from a noise monitor, and to integrate and present them, for instance, to your own website. And I'm going to show you an example here from one of our customers. Here we see a train station where two noise monitors have been placed, have been installed, and the customer has integrated the data that came back or that have been collected from these noise monitors in its website. So here you see here the results. So anybody who will open this website, who will take a look at this situation, can watch by himself the instantaneous status, the instantaneous sound level at these two locations. Well, I'm already at the point of my practical presentation. You see here I have on my PC a connection to a Noise Scout location. You're going to see that in a minute, which is represented by this netbox and the XL2 with the microphone. But before I take a look on the Noise Scout platform, I would like to briefly show you this WebSocket solution. Here we have a text file with a code example. So this is code that we have written to implement such a WebSocket. If you're interested, please let us know. We will be happy to forward this example code to you. So what we do now, we copy or we save this code, this text file, as an HTML file, and by double-clicking on that, what you see what's happening here. You see now the website. You see a website which shows the real-time data from the noise monitor to which the WebSocket is connected. You see here instantaneously the level, the sound level, A-weighted, slow, from that noise monitor. You see further values, the ones that you have selected in your code. You can see further information like wind speed, wind direction, and so on and so forth. So here you see the raw data coming from that noise monitor, and now it is up to you to use this raw data to present it in an acceptable way on your website. Good. Now I switch over to the Noise Scout platform. Here we see a job. A job is typically a couple of noise monitors that have been located in a certain area, for instance, around this place here. And now let's take a look at one of these specific locations, what we call. So a location represents a noise monitor. Here you see the status panel of the noise monitor. It is running, it is collecting data. You see the real-time level here, the battery status or the power supply status, network status, and so on, the temperature. Here on the right-hand side, we see the map where this noise monitor is located. If we scroll down a little bit, we see the alarms that have been created in the past time. Then you see the periods and the limits, so the definition, the condition that need to be met to create an alarm, of course, if the level exceeds the given limit. Then here we have two charts with the sound level over time for a full day or for the last hour. Then here comes a panel with the individual information for this system self-test. Maybe you know this feature under the abbreviation CIC, charge injected charge. So anyway, CIC is the old abbreviation, but we call it system self-test, which covers better, or which describes better the function of this feature. And last but not least, here a list of incidents that have happened in the past, whether you have started the noise monitor or stopped it, whether the weather station has been activated or not. All this information can be read on this list here. Now let us assume you want to share this information with your customer or with the public. How do you do that? So you click here on the setup icon, you open the setup of that location, and here you see you have a couple of options to address. For instance, you can decide whether the periods and the limits shall be shown to the customer, whether the alarms shall be shown, or the WAV files, the audio recording that are executed when an alarm happens shall be active or not. So you can make your own individual selection, save the changes, and then click here on this chain symbol. And as soon as you do that, a new link will be created and opened. And this link allows now a read-only access to your location. So you can share this link with your customer or even with the public. Everybody who has this link is able to take a look on what is going on here, system status, the map, the alarms, the charts, and the incidents. This is according to your previous selection. This is a public link, but as I stated before, read only. Now going back to the administrator view here with all the information, with all the features, also the possibility to edit everything, I want to show you a little bit more about this system self-test. So for that purpose, I open the settings again. And you see here at the very end, I have the system self-test settings. I can switch that feature off. I can switch it to manual, or I can let the system execute this test once per day, always at midnight, or if you prefer at 4 o'clock in the morning. For instance, if you are monitoring a live event, a concert, probably it's not finished yet at midnight, so you would execute that self-test early in the morning. So I want to show you now how you can prepare that self-test in the very beginning. For that purpose, I need to switch off my noise monitor. Switch off means now in this status, it is not recording any sound level anymore, because the self-test needs to be done in this idle state. So if I scroll down here back to my panel with the system self-test results, you see I have now two options: verify and create new reference. Now let us assume we are setting up the noise monitor and we want to make sure that at the very beginning we know the system is working fine, and we want to create this reference for the following hours, days, or even weeks. So we click here on create new reference, which means that now the behavior of the whole system will be verified, will be measured. And you see here we have a new line with the absolute level values of these frequencies. Remember, I showed you the list of frequencies of harmonics, and for each of these frequencies, we get now an absolute value, the level, as soon as we activate our internal generator. This is our new reference. Now, in the following time, I do it right now, could wait for a day, whatever, I can verify the system. I can make sure it is still behaving the same way. So I click on verify. The system repeats the test. But now it will only show me the difference. And that's what you see on this line here, the difference of the actual measurement versus the previous one versus the reference. And you see there are very, very small deviations. So everything is working perfectly fine. Only in case that here you would notice a major deviation, let's say 1 dB or more, then we know something is wrong. Here the system is passed. Otherwise, the system, the Noise Scout system, would even send out an alarm, a system alarm, to inform you, take care, something is going wrong. The system is no longer behaving as expected. So this is the practical operation of this system self-test. I just showed you the manual operation. Normally this is done automatically. So I switch back my noise monitor to running mode to let it record the sound levels. Two more short hints I want to give you. First of all, every time an alarm is created, I can set up the system in a way that it will record a short audio file with the noise that has happened, the noise that was responsible for this excessive sound level. And you can download these audio files here by clicking on the corresponding links. And the second thing I want to mention, you see up here we have a default logo, but we can replace that with your logo, with the logo from your company. Just please send us this logo and we will individually put it into your Noise Scout platform so that you will always see your own company logo at this location here. Well, let me get back to my webinar presentation, summarize the key information that I have given to you. Remember, the connection between your PC and the noise monitor needs to be established either via mobile data, 3G, 4G, LTE, or alternatively, you can do it with a Wi-Fi network or with a wired LAN connection. Then we have two modes on our Noise Scout platform, either the managed mode, very comfortable but predefined, or the gateway mode, which provides more freedom, but also the necessity to program it by yourself. The data that can be collected from a noise monitor cover, of course, the sound levels, the alarms, optionally the audio files that are recorded every time that an alarm is created. We have even the microphone temperature. This is a new feature as well. The new microphone 2340 also includes a temperature sensor. You can measure and collect this information whenever you want. And in addition, optionally, you can install a weather station together with your noise monitor. Then talking about the data presentation, you can provide the full access to this data or a restricted access. And you can also use this share view of the managed mode for a public display. Furthermore, you can create your own individual presentation on your website, for instance, by using WebSocket, as I showed to you. And the last point I wanted to mention here is the ability to export the data from the Noise Scout platform to the Data Explorer software and to create standardized reports. Well, I'm at the end of my presentation. Before I take a look at the questions that have popped in, just a few more information. Please do not hesitate to ask us whenever you need support from our side. We will be happy to assist you, be it our headquarters or our subsidiaries or partners worldwide. You can download the webinar or take a look at it by using this link. And if you liked our service, our presentation, please take the chance to rate us on Google. We would appreciate that. From my side, I want to thank you very much for your attention. I hope I was able to meet most of your expectations regarding this topic. And of course, I would be very happy to welcome you again at one of our future webinars. Until then, have a good time, stay healthy. Thank you and bye-bye.